Good afternoon, dear students of IT 6208, System Integration and Architecture 1. I am your OLC, Ms. Karen De Lara, and welcome to our virtual class today. So we will be discussing the following: system design, inputs and outputs to system design, types of system design, the concept of documentation, and the various design strategies. So let us first define what is system design. So system design is the phase that bridges the gap between problem domain and the existing system in a manageable way. This phase focuses on the solution domain, example, how to implement. It is the phase where the software requirement specification document is converted into a format that can be implemented and decides how the system will operate. In this phase, the complex activity of system development is divided into several smaller sub-activities, which coordinate with each other to achieve the main objective of system development. So these are the various elements of the system design. So we have identified design goals, system decomposition, identification of concurrency, hardware allocation, data management, global resource handling, software control implementation, and boundary condition. System design takes the following inputs. So we have the statement of work, requirement determination plan, current situation analysis, proposed system requirements, including a conceptual data model, modified DFDs or data flow diagrams, and metadata or data about data. System design also gives the following outputs: infrastructure and organizational changes for the proposed system, a data schema, often a relational schema, metadata to define the tables, files, and columns and data items, a function hierarchy diagrams or web page map that graphically describes the program structure, actual or pseudocode for each module in the program, a prototype for the proposed system. So now let's proceed with the different types of system design. So let's start with the logical design. It pertains to an abstract representation of the data flow, inputs, and outputs of the system. It describes the inputs or sources, outputs or destinations, databases or data stores, procedures or data flows, all in a format that meets the user requirements. While preparing the logical design of a system, the system analyst specifies the user needs at level of detail that virtually determines the information flow into and out of the system and the required data sources. Data flow diagram or DFD and entity relationship diagram or ER diagram modeling are used. Next, we have the physical design. It relates to the actual input and output processes of the system. It focuses on how data is entered into a system, verified, processed, and displayed as output. It produces the working system by defining the system specification that specifies exactly what the candidate system does. It is concerned with user interface design, process design, and data design. So the physical design consists of the following steps: specifying the input and output media, designing the database, and specifying backup procedures. Next, we have planning system implementation, devising a test and implementation plan, and specifying any new hardware and software. Updating costs, benefits, conversion dates, and system constraints. Next, we have the architectural design. So it is also known as high-level design that focuses on the design of system architecture. It describes the structure and behavior of the system. It also defines the structure and relationship between various modules of system development process. Next, we have the detailed design. It follows architectural design and focuses on development of each module. Next, we have the conceptual data modeling. It is representation of organizational data, which includes all the major entities and relationship. System analysts develop a conceptual data model for the current system that supports the scope and requirement for the proposed system. So the main aim of conceptual data modeling is to capture as much meaning of data as possible. Most organizations today use conceptual data modeling using entity relationship model, which uses special notation to represent as much meaning about data as possible. So now let's further discuss the concept of entity relationship or ER model. It is a technique used in database design that helps describe the relationship between various entities of an organization. So the following are the terms used in ER model. We have the entity. It specifies distinct real-world items in an application. For example, we have vendor, item, student, course, or teachers. For the relationship, so they are the meaningful dependencies between entities. For example, we have the vendor supplies items, teacher teaches courses, then supplies and course are known as relationship. Next, we have attributes. It specifies the properties of relationships. For example, vendor code or student name. Next, let's proceed with file organization. So it describes how records are stored within a file. And there are 4 file organization methods. We have serial. Records are stored in chronological order, in order as they are input or occur. Examples, recording of telephone charges, ATM transactions, or telephone queues. Second, we have the sequential. Records are stored in order based on a key field which contains a value that uniquely identifies a record. For example, we have phone directories. Next, we have direct or relative. Each record is stored based on a physical address or location on the device. Address is calculated from the value stored in the record's key field. Randomizing routine or hashing algorithm does the conversion. And next, we have indexed. So records can be processed both sequentially and non-sequentially using indexes. Now, let's proceed with file access. So the file access is a methods which allow computer programs to read or write records in a file. We have the sequence access. So every record on the file is processed starting with the first record until end of file is reached. It is also efficient when a large number of the records on the file need to be accessed at any given time. Data stored on a tape or sequential access can be accessed only sequentially. Next, we have direct or random access. So records are located by knowing their physical locations or addresses on the device rather than their positions relative to other records. Data stored on a CD device or direct access can be accessed either sequentially or randomly. So following are the different types of files used in an organization system. So we have the master file. It contains the current information for a system. For example, we have the customer file, student file, telephone directory. Next, we have the table file. It is a type of master file that changes infrequently and stored in a tabular format. For example, storing zip code. Next, we have transaction file. It contains the day-to-day information generated from business activities. It is used to update or process the master file. For example, addresses of the employees. Next, we have the temporary file. It is created and used whenever needed by a system. Mirror file, they are the exact duplicates of other files, help minimize the risk of downtime in cases when the original becomes unusable. They must be modified each time the original file is changed. Next, we have log files. They contain copies of master and transaction records in order to chronicle any changes that are made to the master file. It facilitates auditing and provides mechanism for recovery in case of system failure. Next, we have the archive files. So these are the backup files that contain historical versions of other files. Now, let's proceed with the concept of documentation. So documentation is a process of recording the information for any reference or operational purpose. It helps users, managers, and IT staff who require it. It is important that prepared document must be updated on a regular basis in order to trace the progress of the system easily. After the implementation of system, if the system is working improperly, then documentation helps the administrator to understand the flow of data in the system, to correct the flaws and get the system working. Programmers or systems analysts usually create program and system documentation. Systems analysts usually are responsible for preparing documentation to help users learn the system. In large companies, a technical support team that includes technical writers might assist in the preparation of user documentation and training materials. So, what are the advantages of documentation? One, it can reduce system downtime, cut costs, and speed up maintenance tasks. Two, it provides the clear description of formal flow of present system and helps to understand the type of input data and how the output can be produced. Three, it provides effective and efficient way of communication between technical and non-technical users about the system. Four, it facilitates the training of new user so that he can easily understand the flow of the system. Five, it also helps the user to solve the problems such as troubleshooting and helps the manager to take better final decisions of the organization system. And lastly, it provides better control to the internal or external working of the system. So what are the different types of documentations? So when it comes to system design, there are four main types of documentations. So we have the program documentation, system documentation, operations documentation, and user documentation. So let us further discuss one by one the different types of documentations. So let's start with program documentation. It describes inputs, outputs, and processing logic for all the program modules. The program documentation process starts in the system analysis phase and continues during implementation. This documentation guides programmers who construct modules that are well supported by internal and external comments and descriptions that can be understood and maintained easily. Next, we have operations documentation. It contains all the information needed for processing and distributing online and printed output. Operations documentation should be clear, concise, and available online if possible. So it includes the following information: program, systems analyst, programmer, and system identification, scheduling information for printed output, such as, for example, report, execution frequency, and deadlines. Input files, their source, output files, and their destinations. Email and report distribution lists, special forms required, including online forms, error and informational messages to operators and restart procedures, special instructions such as security requirements. Next, we have user documentation. It includes instructions and information to the user who will interact with the system. For example, user manuals, help guides, and tutorials. User documentation is valuable in training users and for reference purpose. It must be clear, understandable, and readily accessible to users at all levels. So the users, the system owners, the analysts, and programmers all put combined effort to develop a user's guide. So a user documentation should include the following: a system overview that clearly describes all major system features, capabilities, and limitations, description of source document content, preparation, processing, and samples, overview of menu and data entry screen options, contents, and processing instructions. Examples of reports that are produced regularly or available at the user's request, including samples, security and audit trail information. It also includes explanation of responsibility for specific input, output, or processing requirements, procedures for requesting changes and reporting problems, examples of exceptions and error situations, frequently asked questions, explanations of how to get help, and procedures for updating the user manual. Next, we have system documentation. It serves as the technical specifications for the IS and how the objectives of the IS are accomplished. So users, managers, and IS owners need never reference system documentation. System documentation provides the basis for understanding the technical aspects of the IS when modifications are made. It also describes each program within the IS and the entire IS itself. It describes the system's functions, the way they are implemented, each program's purpose within the entire IS with respect to the order of execution, information passed to and from programs, and overall system flow. It includes data dictionary entries, data flow diagrams or DFDs, object models, screen layouts, source documents, and the system's request that initiated the project. So most of the system documentation is prepared during the system analysis and system design phases. So during systems implementation, an analyst must review system documentation to verify that it is complete, accurate, and up to date, and including any changes made during the implementation process. Next, let's proceed with design strategies. So first is the top-down strategy. So it includes the modular approach to develop the design of a system. It is called so because it starts from the top or the highest level module and moves towards the lowest level modules. In this technique, the highest level module or the main module for developing the software is identified. The main module is divided into smaller or several smaller and simpler submodules or segments based on the task performed by each module. Then each submodule is further subdivided into several submodules of next lower level. So this process of dividing each module into several submodules continues until the lowest level modules, which cannot be further subdivided, are not identified. So we have here a sample illustration of the top-down strategy. So it starts with the main module, level 0, followed by level 1, submodule 1, 2, and 3, and level 2, which is submodule 1.1, 1.2, 2.1, 2.2, 3.1, and 3.2. Next, we have the bottom-up strategy. So it follows the modular approach to develop the design of the system. It is called so because it starts from the bottom or the most basic level modules and moves towards the highest level modules. In this technique, the modules at the most basic or the lowest level are identified. And these modules are then grouped together based on the function performed by each module to form the next higher level modules. Then, these particular modules are further combined to form the next higher level modules. So this process of grouping several simpler modules to form higher level modules continues until the main module of the system development process is achieved. So this is an illustration of how the bottom-up strategy looks like. So it starts with level 2 or the submodule 1.1, 1.2, 2.1, 2.2, 3.1, and 3.2, followed by level 1, submodule 1, 2, and 3, and the main module, which is the level 0. Next, we have structure design. So it is a data flow-based methodology that helps in identifying the input and output of the developing system. So the main objective of structure design is to minimize the complexity and increase the modularity of a particular program. So structure design also helps in describing the functional aspects of the system. In structure designing, the system specifications act as a basis for graphically representing the flow of data and the sequence of processes involved in a software development with the help of DFDs or data flow diagrams. So after developing the DFDs for the software system, the next step is to develop the structure chart. So these are some of the examples of a structure design. So we have the system identification, DFD, data dictionary, structured English, decision tree, and decision table. So next we have modularization. So the structure design partitions the program into smaller and independent modules. So these are organized in top-down manner with the details shown in bottom. So that structure design uses an approach called modularization or decomposition in order to minimize the complexity and to manage the problem by subdividing it into smaller segments. So what are the advantages of modularization? First, critical interfaces are tested first. It provides abstraction. It allows multiple programmers to work simultaneously. It allows code reuse. It provides control and improves morale. And it makes identifying structure easier. So next we have structured charts. So structured charts are a recommended tool for designing a modular top-down systems which define the various modules of system development and the relationship between each module. It shows the system module and their relationship between them. It consists of diagram consisting of rectangular boxes that represent the modules connecting arrows or lines. For the structured charts, we have the control module and the library module. So the control module is a higher level module that directs lower level modules known as subordinate modules. And the library module is a reusable module and can be invoked from more than one point in the chart. So here is an example of how the structured chart looks like. So we have the module 1, and this module 1 is subdivided into module 1.1, 1.2, and 1.3. And module 1.1 and 1.2 are considered as the subordinate module, while module 1.3 is considered as the library module. So we have two different approaches to design a structured chart. First, we have transform-centered structured charts. So they are used when all the transactions follow the same path. while the other one is the transaction centered structured charts. So they are used when all the transactions do not follow the same path. So what are the objectives of using structure flowcharts? So first is to encourage a top-down design. Second is to support the concept of modules and identify the appropriate modules. Third is to show the size and complexity of a system. Fourth is to identify the number of readily identifiable functions and modules within each function. And lastly is to depict whether each identifiable function is a manageable entity or should be broken down into smaller components. So let us review what we have discussed today. So we have defined first what is system design. So again, system design is included in the system development life cycle. And we basically use various tools for system design or for designing a particular system. Then these are the inputs to system design as well as the outputs for system design. Then we also discussed the different types of system design. So we have the logical design. So this logical design can be represented by flowcharts, data flow diagram, or ER diagram modeling. Next, we have the physical design, which basically concentrates on the interface design. And then next, we have the architectural design and the detail design. Then we also discuss what is a conceptual data modeling. And then we further explain the elements and concept of the entity relationship model or the ER model. Then we also mentioned the 4 file organization methods, which are serial, sequential, direct or relative, and indexed. Then for the file access, we have discussed and defined sequential access, direct random access, and then the different types of files used in an organization system. So we have the master file, the table file, transaction file, temporary file, mirror file, log files, and the archive files. Then we also discuss the definition and concept of documentation, and as well as its features and advantages. And we also mentioned the different types of documentation, such as the program documentation, the operations documentation, the user documentation, and the system documentation. Then with regards to design strategy, so we have mentioned the top-down strategy, which starts with the highest level module and moves towards the lowest level module. Then the bottom-up strategy, which starts with the most basic level and moves towards the highest level module. Then we also discuss what is a structure design. So basically, it concentrates on identifying the input and output of a particular system. Then we also discuss what is modularization. So basically, modularization is also known as decomposition and its advantages. Then for the structure charts, we have mentioned the two elements, the control module and the library module. Then the two different approaches are the transform-centered structured charts and the transaction-centered structured charts. And we also enumerated some of the objectives of using the structured flowcharts. So if you have any questions, please send a message through the LMS chat box, or you can also email me at kvdelara@amais.edu.ph.